Nuclear energy boiler recyclable. Overview. I'm going to go over an introduction, background, production, some advantages and disadvantages, and a conclusion. Introduction. I'm going to start off by reading this quote. The nuclear power plant stands on the border between humanity's greatest hopes and its deepest fears for the future. Instead of using fossil fuels, natural gas, and coal, we're striving for cleaner ways of producing electricity, such as solar energy, wind energy, and hydroelectric energy. But the world requires a base load energy, meaning a reliable energy being produced daily. Nuclear power is one of few base load energies in the world today that give off low greenhouse gas emissions per unit of energy generated. Background. The idea of using nuclear reactions to generate energy was first put into practice in the early 1940s by the famous Italian physicist Enrico Fermi. The majority of nuclear power is generated by nuclear fission, the exothermal chain reaction of breaking a bigger atom into multiple smaller atoms. Nuclear fission was the first experimental confirmation of Albert Einstein's equation E=mc², which states the equivalence relation between energy and mass. This concept motivated people to invest in nuclear physics in hopes of converting mass into energy. Production. Nuclear power plants utilize the thermal energy generated by nuclear reactions to manipulate water, which in turn drives a turbine that converts kinetic energy into electricity. There are two main types of nuclear reactors: pressurized water reactors, in this diagram ahead, and boiling water reactors. Pressurized water takes advantage of water circulation to generate electricity. The nuclear reaction takes place in a reactor vessel controlled by a pressurizer and control rods. The vessel is enclosed by a body of water, and the container of the water is attached to a turbine that drives a generator. The thermal energy generated by the nuclear reaction manipulates the water circulation, causing hot water to rise. On the other side of the water container there is a condenser, which contains coolants required to sustain the circulation process. The choice of coolant is usually cold water from a large lake for practical reasons. Due to such choice of coolant, nuclear power plants are normally built near a large body of water. For the boiling water reactor, the process is similar to that of the pressurized water reactor, but the water is boiled instead of circulated. Disadvantages and advantages. Two disadvantages to nuclear power are nuclear waste and nuclear disasters. The waste produced by nuclear reactors needs to be disposed of at a safe place since they are extremely hazardous and can leak radiations if not stored properly. The nuclear power plants require a large body of water as a coolant, most often a lake, to the point of destroying the biome, thus causing a chain reaction affecting nearby plants and animals. The byproduct of nuclear power plants are radioactive and hazardous to most life forms and environments. The nuclear waste will decay naturally over time, so the current method of management is segregation. Overall, the amounts of waste produced by nuclear power plants are very small relative to other forms of energy production methods. The large amount of energy produced in the condensed place makes the outcome of mishaps extreme. Under certain circumstances, explosion may occur, destroying any nearby area. Other forms of danger include leakage of radioactive materials, which may affect a large area around the facility, damaging most life forms for years to come. Many nuclear disasters have occurred in the past and are probable to occur once more. Examples of nuclear disasters are Fukushima, and Chernobyl. These disasters are either seriously harmed the environment around them, harmed civilians, or killed hundreds of people in their surroundings. Fukushima disaster occurred in 1957 and is the third biggest nuclear disaster to date. It occurred due to a tank carrying about 70 tons of radioactive waste, failing then exploding. Although they evacuated thousands of people in the surrounding areas afterwards, they kept the disaster a secret for about 30 years. Fukushima, on the other hand, was known right away. They evacuated over 1,000 people, and as a result, no sign of death caused by the nuclear accident. Advantages: low greenhouse gas emissions, efficiency, and reliability. It is well known that climate change is a serious issue. The greenhouse effect is influenced greatly by high carbon dioxide emissions from other forms of electricity productions. Nuclear power plants emit less carbon dioxide than most conventional ways of producing energy, such as oil, natural gas, and even photovoltaic energy. In the fission of uranium-235 nucleus, the amount of energy released is about 60 million times as much when a carbon atom burns, meaning that it takes very little uranium-235 to generate large amounts of electricity. From a physics standpoint, the nuclear reaction simply generates more efficiently than all other forms of electricity generation. Reliability should also be taken into consideration when looking at power generation. Being environmentally friendly like solar and wind energy is an advantage, but an advantage compared to solar and wind energy is the fact that nuclear energy is a baseload power, can be produced at any given time on any given day. It doesn't rely on the wind to blow or the sun to shine, which gives it a major advantage compared to other green energies. Conclusion. To conclude, nuclear energy has its advantages and disadvantages. The nuclear energy can be a potential hazard to a society, or it could be a solution to our global concerns regarding climate change. We can look at the constraints and look for ways to prevent accidents and utilize waste to our advantage. With that in mind, nuclear energy has a lot of potential and can help reduce greenhouse gases and contribute to the energy production. It is time to weigh our options and do what's best for our society. Thank you.